We've been talking about quadratic equations and various ways to solve them. Now we're going to apply them to the solution of actual problems. So in our first problem here, we're asked to find the product of two consecutive even integers. We're told that that product is 48. So we need to figure out how are we going to write an equation to show that the product of two consecutive even integers is 48. Well, if you choose n to be the first integer, if they're consecutive and even, that means they are 2 units apart. So n plus 2 would be the second integer, and their product would mean you multiply them together. So if we want to do the guess and check method, we can pick an even number for n because it did say they have to be even. Well, the product has to be 48.
What?
So we have to, when we do our multiplication, see if this answer is going to come out to 48. So let's say I start with 2. It doesn't make sense to start with 0 because 0 times anything is 0. But 2 and 2 plus 2 is 4. 2 times 4 is 8. Well, that's too small, so I need to go bigger. And it seems like I need to go quite a bit bigger, but let's hang on. So the next even number would be 4. N plus 2 would be 6. 4 times 6 is 24. Well, that jumped up quite a bit closer, but it's still not big enough. So if we try 6, 6 plus 2 is 8. 6 times 8 is 48. So by the guess and check method, we find that our two even integers are 6 and 8. Well, that's great when your numbers are small and easy to work with, but sometimes they're not so small and easy to work with, so you need to be able to come up with a way of writing an equation that you can solve to find the solutions. So the algebraic approach to this has a lot to do with these values right here. The n is our first integer, n plus 2 is our second integer, and we are multiplying those together to get 48. So how do I know this is a quadratic equation? Well, when I multiply this out, I'm going to get n squared plus 2n equals 48. And the highest power of the variable is 2. And that's what makes it quadratic. Well, when we have a quadratic equation where we have the variable in more than one term, we want to get 0 on one side. So I'm going to subtract this 48 from both sides. And that gives me n squared plus 2n minus 48 equals 0. Well, because the leading coefficient is 1, the first thing I'm going to do is try to factor this. When the leading coefficient is 1, we just start with the variable at the beginning of both parentheses, and we need factors of 48 that subtract to give us 2. Well, factors of 48 can be 1 and 48, 2 and 24, 3 and 16, 4 and 12, or 6 and 8. And when I subtract those, the only pair that gives me 2 are 6 and 8. The subtraction means these have to have different signs, and this sign means the bigger product has to get the plus sign. So the bigger product is the 8n. So the 8 gets the plus sign, the 6 gets the minus sign. And that tells us either that n is 6 or n is negative 8. Well, n was the first of your consecutive even integers. So that means my first integer could be 6 and the second one would be 8. But this is telling me there's another answer. If my first integer is negative 8 and I add 2 to that, I get negative 6. And when I multiply these two together, I also get 48. since the problem didn't say that the numbers had to be positive, here I found two sets of answers. The two numbers could be either 6 and 8 or -8 and -6. So that's why guess and check isn't always the best method to use, because you may miss some answers. Because generally when people guess and check, once they find an answer, they stop. And with quadratic equations, there are usually two answers. Okay, so looking at the second exercise, we want to find 3 consecutive positive integers such that the product of the first two is 22 less than 11 times the third. Well, break this, it sounds pretty complicated, but break it down a step at a time. We want 3 consecutive positive integers. So we're going to have 3 separate variable expressions, and they're going to be positive, and they're going to be consecutive. Notice it didn't say that they were even. So consecutive numbers are only 1 digit apart. So if our first number is n, our second one is going to be n plus 1, and our third one is going to be n plus 2. So our first, second, and third numbers. Now, the product of the first two would be n times n plus 1. Is our equal sign. 22 less than means I'm taking 22 away from 11 times the third. Well, that's going to be 11 times n plus 2. So this is my equation. The product of the first two consecutive integers is 22 less than the product of 11 and the third integer. So I'm going to distribute to see what both sides are going to come out to here. On this side I get n squared plus n. On this side I get 11n plus 22 minus 22. Well, the plus 22 and the minus 22 cancel out. I have a quadratic equation because the highest power is 2. But I have multiple terms including the variable, so I want to get 0 on one side. So I'm going to subtract 11n from both sides. I'm going to go over here. So that gives me n squared minus 10n equals 0. So now that we have 0 on one side and it's in standard form, we factor. Well, there's a common factor here of n. If we divide n out of n squared, that leaves n. And if we divide n out of negative 10n, we get negative 10. Now we have a product equal to 0. So by the zero product rule, we can set each factor of that product equal to 0 and solve for the variable. Well, n equals 0 is already solved. Here we would add 10, and we get n equals 10. So the two possible solutions for our first digit are either 0 and 10. So if our first digit is 0, then we would get 0, 1, and 2 for our 3 consecutive digits. If our first digit is 10, we get 10, 11, and 12. So it might be worth checking this. 0 times 1 is 0. 11 times 2 is 22, minus 22 is 0. So the solution 0, 1, 2 works. Now going back, 10 times 11 is 110. 11 times 12 is 132, minus 22 is 110. So this solution also works. In this problem, they want 2 consecutive odd integers to be equal to 30 more than the first integer. So we need two consecutive integers, consecutive odd integers. Well, consecutive odd numbers are 2 digits apart. I know 2 isn't odd, but if you go from 1 to 3, it's 2 units apart. So if we call our first integer n, and it's odd, then n plus 2 would be the next consecutive odd integer. It says that their product, which would be n times n plus 2, is equal to 30 more than, so we're adding 30 to the first, which was the n. So this is the equation we need to solve. Distribute, and we get n squared plus 2n equals n plus 30. It's quadratic, since the highest power is 2, and there are more than one term with different powers that have n in them, so we want to get 0 on one side. So I'm going to subtract n from both sides, and I'm going to subtract 30 from both sides. So we get n squared plus n minus 30 equals 0. Now we need to solve. Since the leading coefficient is 1, we can try to factor by just choosing n and n to lead off our parentheses. The factors of 30 that subtract to give us 1. Well, the factors of 30 are 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And the only ones that subtract to give us 1 are the 5 and the 6. So, different signs. The bigger one gets the plus. So they have different signs. The bigger one is the 6, it gets the plus. The 5 gets the minus. So we set each of these equal to 0. And we'd add 5 to get n equals 5. Or we'd subtract 6 to get n equals negative 6. So it looks like we're going to have two answers again. However, it said they had to be two consecutive odd integers, and 6 is not odd. So I disregard that solution. So the two consecutive odd integers, the first one would be 5, and then 5 plus 2 would give me 7. So if we check our problem, the product of these is 35, and that is 30 more than 5. Okay, another problem. An object's moving in a straight line. It starts out by traveling a speed of 9 meters per second, and it speeds up at a constant rate of 2 meters per second. Under such conditions, they tell you the d in meters is equal to the equation d equals t squared plus 9t, where t is in seconds. According to this equation, how long will it take the object to travel 22 meters? Well, they gave us the equation d equals t squared plus 9t, and they said the distance they want it to travel is 22 meters. So we substitute 22 in for our d. It's a quadratic equation because the highest power on the variable is 2. And there are two terms with different powers that include the variable, so we need to get 0 on one side. So we're going to start by subtracting 22 from both sides. That gives us 0 equals t squared plus 9t minus 22. Now we factor. The leading coefficient's 1, so starting them off is easy with the t and the t. Factors of 22 that subtract to give us 9. Well, the factors of 22 are 1 and 22, or 2 and 11. And the 2 and the 11 are the ones that subtract to give us 9. Because this is negative, these have to have different signs, and the bigger one has to get the sign of the middle. So it's plus on the 11 and minus on the 2. So now I'm going to go over here. We set each factor equal to 0. and solve for t. So here we'd add 2. Here we'd subtract 11. Now, it tells you that t is in seconds, and it wants to know how long it will take. Well, since we live in a linear universe where time proceeds in one direction, we don't talk about the time before we started counting. So our time can't be negative 11. So 2 is the time where it would have traveled 22 meters. After 2 seconds, it will have traveled 22 meters. If you want to check it, 22, 2 squared is 4, 9 times 2 is 18, 4 plus 18 is 22. In this problem, we have a rectangle. First thing I'm going to do is draw a rectangle. And it says its width is 2/3 of its length. So if this is its length and this is its width is equal to 2/3 of its length. So that's 2/3 L. And it says the area is 294 square inches. Well, the area of a rectangle is its length times its width. So that means the area of this rectangle is going to be its length times 2/3 of its length. So that's 2/3 times its length squared. And they tell us that that area is 294 square inches. So this is the equation we need to solve. Well, the variable is squared, so it's quadratic, but there's only one term that has the variable in it, so I want to isolate this term instead of getting 0 on one side. So first I need to get rid of the 2/3 by multiplying by its reciprocal, 3/2. So these cancel, leaving the L squared. So 2 into 294 goes 147, and then 3 times 147 is 300, 420, 441. And then to get rid of the squared, we take the square root of both sides. Now, when we take the square root, we need to remember the plus or minus. But in this problem, L stood for a length, and we don't talk about lengths being negative, so we're not going to need the negative answer. And then you need to find the square root of 441. Well, I happen to know that that is 21. So the length of this picture is 21 inches. The width is 2/3 times the length. 3 goes into 21 7 times 2 is 14 inches. So the picture is 14 inches wide by 21 inches long. The next example is very similar. It says a square is altered so that one dimension is increased by 4 while the other is decreased by 2. So if we start with a square, and we'll call each side of these squares x, if we increase this side by 4, so this becomes one side, and we decrease the other side by 2, so this x was for the whole thing. So we're cutting it off here. Then the square that we're left with, which is this one, well, it's actually a rectangle that we're left with, has a length of x plus 4 and a width of, remember, x was this whole thing, so to get this, we're going to do x minus 2. And it says that the area of the resulting rectangle is 55. And again, area is length times width. So our length is x plus 4, our width is x minus 2. Our area was 55, and that's equal to x plus 4 times x minus 2. Now you might look at that problem and say, that's already factored, I can solve it now. But factoring does you no good if the other side isn't 0. So you have to multiply this side out so you can rearrange things to get 0 on one side. So we get x squared minus 2x plus 4x minus 8. And then we combine like terms, so the plus 4x and the minus 2x give us plus 2x. And I would have to subtract the 55 from both sides. Since these have the same sign, I add them together and keep the signs, and that gives us minus 63. So we have 0 equals x squared plus 2x minus 63. Now, because we have 0 on the other side, we factor. Our leading coefficient is 1, so we start with x in both parentheses. And we need factors of 63 that subtract to give us 2. Well, the factors of 63 are 1 and 63, 2 doesn't go, 3 and 21, 4 doesn't go, 5 doesn't go, 6 doesn't go, 7 times 9, and 8 doesn't go, and that meets in the middle. And the only pair of these that subtract to give us 2 are the 7 and the 9. They have different signs because of the minus here. The bigger product gets the plus, so that means it's plus on the 9, minus on the 7. So when we set x minus 7 equal to 0, we add 7 to both sides to get x equals 7. And we set x plus 9 equal to 0. We subtract 9, we get x equals negative 9. Well, x was a length, and it can't be negative, so we throw that answer out, and the length of the original side of the square was 7. But the problem asks us find the area of the original square. Well, the area of a square is the length of its side squared. So that would be 7 squared, which is 49, and this would be square units because they didn't tell you whether they were inches or whatever. Last example. The profit in dollars gained by selling X computers is modeled by the equation P equals negative 5x squared plus 1,000x plus 5,000. How many computers must be sold to obtain a profit of $55,000? Well, we're going to plug 55,000 in for P and solve it for X. Now notice again, we've got x squared as our highest power, so it is quadratic. It has 2 terms involving x, so I want to get everything on one side and 0 on the other side, so I'm going to subtract the 55,000 from both sides. So I get 0 equals negative 5x squared plus 1,000x minus 50,000. Now, our leading coefficient isn't 1 this time yet, but remember the first step when you're factoring is always to look for a common factor. And 5 definitely goes into all 3 of these numbers. Not only that, but when we're factoring, we kind of like our leading coefficient to be positive, so I'm going to factor out negative 5 from this expression. So when I divide it out of the first term, I'm left with x squared. When I divide it out of the second term, I get minus 200x, because when I multiply this negative times this negative, I get the positive there. And when I divide the 50,000 by negative 5, the negatives cancel, and I get 10,000. Now, our numbers are a little bigger here. So we might want to try other methods than factoring, but we haven't really talked about the quadratic formula yet, so let's stick with our factoring. It's not too bad because, not 0.5, just 5, negative 5. It's not too bad because the leading coefficient is 1. So we just start with x and x. And we need factors of 10,000 that add up to 200. Well, 10,000 has a whole lot of factor pairs. And I'm not going to start with 1 in 10,000 because if they're going to add up to 200, then the biggest factor can't be more than 200. So I'm going to start with 200 and work my way down. If I divide 10,000 by 200, I get 500. Too big. Those don't add up to 200. So let's jump down to 100. If I divide 10,000 by 100, I get 100. And 100 plus 100 is 200. So I'm going to get x with 100 here. Another thing you may have realized, this is a perfect square and 10,000 is a perfect square. And when you take their square roots and multiply them together and double them, you get the middle. So another way to write this is negative 5 times the quantity x minus 100 squared. So there's only one thing you have to set equal to 0. If x minus 100 equals 0, then you add 100 to get x equals 100. And that would be 100 computers in this case.